Good afternoon, everybody. So I'm going to talk to you a little bit about Scala and a little bit about Java, mostly about Scala. Before I get started, mostly familiar with the JVM, kind of just here to see what's out there. Like, how does the room fall on that? Like, who's used Scala before? Okay, excellent. So that answers that question. So I'm the team lead at Lightbend. Besides renaming companies and stuff like that, we also develop a compiler and a standard library. So who are we? Well, we're a team of a pretty small team of 5 people in most recently joined order. So there's Stefan Zeige, Seth Tishu, Lucas Ritz, me, and Jason Zauk. I think roughly all of us have been working on Scala for about a decade each. So you can do the math how much that's between us. And yeah, so I'm basically going to talk a bit about what we've been up to, what we're going to be up to very soon, and a little bit of why also. If there's anything unclear right away that would keep you from following the rest of the presentation, feel free to interrupt me. Otherwise, I'll just take a bunch of questions at the end. So, you know, we're a pretty small team, but I'm pretty proud to do the stats and see that we did about a release every 6 weeks on 2.11, 2.10, and 2.12 milestones last year, including this first quarter. So yeah, we've been pretty busy. That's what we've been up to, and so we're going to keep doing that. So we just released M4. I'm about to hit the merge button on putting that on Scala Lang. M5 will be next. And then a bunch of 2.12 minor releases, and probably one more 2.11 this summer. What am I most excited about? I figured that might be on your mind as well. So we're all very excited about compiling to Java 8 bytecode. It's a great opportunity for Scala, and I think we've been using that well, and I'm excited to see what you all are going to do with it in 2.12. So that's what I'm going to talk about the rest of the talk. Let me talk about a couple things that I'm also very excited about, but I won't have time to talk about too much today. So we finally merged and standardized on the new backend and optimizer that's been in the works for years now. Miguel Garcia started that at EPFL when we were both postdocs there. But Lucas has done some really tremendous work on actually making that production ready and testable and, you know, robust and all that. And so it's ASM based, the backend, Gen B code backend. We removed the old ones, the Gen I code and the Gen ASM one. And so now we can finally inline from traits. So those of you who've been using Scala for a while know how excited we are about that. It does a lot better job at eliminating closures and some common box-on-box operations like tupling and untupling immediately that the pattern matcher tends to do, for example. He gave a great talk about that recently. That you can take a look at if you're interested. And the number one complaint we get about Scala, of course, is that it's slow to compile. And yeah, it's hard to compile this quickly, and we try to make it compile more quickly, obviously. But we're betting big on incremental compilation, and we've already made a lot of progress there. I think I'm very happy with the work that Jagos has been doing on this. And there's a couple more improvements coming very soon to the next SVT releases that make it more fine-grained and more efficient. So, and for the last part of this section, I'm also really happy with the community. It's ups and downs, obviously, as all communities, and it's easy to forget that most people there are very friendly and inclusive, and I'm proud of that. And we definitely want to collaborate with everybody to make that happen. One thing that, while we're on that topic, that I want to personally mention is that I think it's important not to be too passionate about what we're doing. It's a job. It's a thing that we're doing, a tool that we're using. It's not who we are. It's not our identity. So I think there's a danger of getting too passionate about something that makes you blind to its deficiencies, or not listen to the criticism, the reasonable criticism that we get. And I think it's also important to just be kind to each other, and not just because I like kind. And it's a growing community. Very nice to see new faces on every milestone's release notes, and it's very gratifying to see that. So thank you all for using Scala, for contributing to it. And on our end, we're doing our best. We're doing what we can with a small team and the limited resources of a startup to get you as involved as we can in the process. And of course, there's the Scala Center. Heather is here. She gave a talk this morning, who's leading the Scala Center at EPFL. But we also invested in more pedestrian things like getting our PR validation running more quickly on EC2, and it's all open source, the way that it's implemented, standardizing the way that the compiler is built, so you can just clone the repository, open your favorite IDE, import the project, and immediately get productive instead of having to learn the ins and outs of our old and build. The modularization, the reason we did that, there are plenty of reasons to do that, but one of them is to let the community own some of the modules, and for every module that we removed from the core in 2.11, at least one person stepped up to maintain it and is maintaining it. So that's very good to see, and we will continue that in 2.13. So 2.12, what I'll talk about today, is a compiler release. So we try to alternate to keep the changes small. So this time we were focusing on improving the compiler. Next time we'll focus on improving the library. Obviously, it targets Java 8. It requires Java 8 because we want to use all the good stuff that's in there. It has a new optimizer. This is a slide that I presented about a year ago. So for honesty, I crossed out what we didn't do or didn't have time to do. Abide is our compiler plugin framework to do analyses in the compiler. And it's out there, but we don't really have time to develop it further, and so people are welcome to pick it up. And then if you interpret Q1 as January 1st and Q2 as June 30th, we're about 6 months late. And that's usually how these things are interpreted. So yes, we're about 6 months late. And that's mostly because we did a lot of work on 2.11 to make sure that everything we could do in 2.11 ended up being done in 2.11 so that those that can't upgrade to Java 8 can still use these features before the big jump. This decision was made a couple of years ago when it wasn't clear what the uptake of Java 8 would be like, and I think it's been tremendous, and so now it's kind of like, why did you even worry about this? But we're a pretty cautious bunch, and so we were a little worried about that, but I see now that wasn't really necessary. Quickly about 2.13, which we called AIDA in our original plans because we didn't really want to commit to version numbers, I guess. Expect that in about 18 months after we're done with the initial polish for 2.12. We already have a roadmap up that accurately reflects what our plans are still. So like I said, it's going to be a library release. The collection API, I'm proud of its design, and I think it's very usable, but it has its warts. It's grown over the years. It's gotten a little too complicated internally. So we're going to spend some time pruning and making it easier to use and expose less of its internals. So if you are extending the collections or if you are doing some pretty crazy things with them, pay attention to the 2.13 early milestones. You'll see some changes in there. We already made a lot of classes final that should have been from the start. Yes, question in the back.
Are you going to do anything with Java conversions or Java converters?
Oh, yeah. You mean as in pick one?
Or get rid of both?
So the question is about the two kinds of converters that we have between Java collections and Scala collections. At the very least, we're going to pick one. And the as Scala as Java variant is going to be the one that probably is least surprising. We're also working on Scala Java 8 Compat, which is a new library that is available for 2.11 and 2.12 milestones. That's more focused on integrating with streams, but some of that will also kind of grow into more general converters between Java collections and Scala ones. But yes, that's one of the examples where I was kind of referring to, like, it's grown organically over the years. Once in a while, it's time to say, well, look, what was a good idea, what wasn't in hindsight, and then act on that. And we'll go through a deprecation cycle first. We're not just going to throw it all out. But I do want to remove deprecated things where possible. We don't want to just gratuitously break your code, of course, but it has to remain manageable. Okay. So that naturally leads to a couple of modules. We haven't really committed to anything here yet, but we have been working on Java 8 streams interop, for example. And our views are one of the weaker parts of our collections API, so that's definitely something that needs some love. The parallel collections is a prime candidate to pull out because it's one of the core reasons why the hierarchy got so complicated. And there's really not that much value in abstracting over sequential and parallel collections. And something like validation comes up a lot. And we think maybe it'll make sense to provide like a standard module rather than having you pick between the Scala Z1 or the one by Bill Venners or by someone else. I know that there are several out there. So macros, I mean, the first thing I always tell people about macros is not to use them. And yeah, that's really all I'm going to say about that today as well. So you can ask me questions about them later if you want. I'm just going to repeat the official stance. And that's not tongue-in-cheek, by the way. Like, we're serious about this being experimental, and I kind of have informally suggested that we just write a tool to rename all methods kind of randomly to make sure that you feel like the pain you're going to feel when the actual implementation of the compiler changes in future versions. And a lot of stuff is going to seemingly gratuitously change because, let's face it, the compiler was never really meant as an API. It wasn't meant to be used by anyone internally, the code. It was meant to be used by users from the command line. It wasn't meant to be called into programmatically. Yet we made it available to you and you did great things with it. But I hope you're ready to follow up when all these things change under the hood. But that's, in my opinion, years away. So Don Giovanni is a longer spelling of Dottie. And if I have any say in it, it'll be in two acts. First, I want to take all the good stuff that they've been doing and rework the backend and maintain full source compatibility with 2x, whatever the x will be by then. And do our usual dance with previewing changes so you can compile under source flags and get the different behaviors and so on where possible. Mostly taking the implementation strategy so we can have a faster compiler. There are some innovations in Dottie that will likely result in faster compilation times, but it's still too early to say. And there's some couple interesting thoughts going on with Tasty to compile to a kind of a richer intermediate representation that would fix some of the binary compatibility problems that we're still facing because we're still pretty far away from the platform, no matter whether it's a JavaScript or JVM. And then the second act, there will be some changes that will require changes to your code. And we'll see how far we can go. But these are some of the I think less controversial ones. Draw procedure syntax, something that will be heavily discouraged during the 2x series as well. Get rid of XML literals. Sorry, JavaScript JSX. You can have the XML literals. I'll tell you the story why XML literals are in Scala sometime over drinks. And then stuff like early definitions, which are really only in the language because the compiler needed them, will go, and we'll just make traits and classes more regular in the way that they take parameters during initialization. And so you'll have trait parameters, just like you have class parameters. So those are all really nice cleanups, and I think sure wins, and things that we'll preview in the 2x series. The more ambitious side of Dottie is exploring the way that the type semantics can be represented differently. And when I was at EPFL, we did a lot of research on proving soundness mechanically of the core calculus. And I mean, I gave numerous talks about the curse of Dottie, the curse of dot, because that's the name of the calculus, and driving lots of postdocs into industry, myself included. And so there's some really interesting stuff going on, but it's also some pretty complicated stuff, and it's hard to say what the impact is going to be on the user. So that, from my perspective, is something that we'll really need to evaluate and make sure that it really brings you the value that will justify the pain of doing the upgrade. This is my personal opinion, by the way. But other less controversial things like, hey, don't define implicits without result types. It's really hard when you're doing type inference and you're trying to decide whether you need to apply an implicit conversion that you then also need to infer the result type of that implicit. And there's lots of hacks in the compiler to make that work right now. I wouldn't ever recommend relying on that or even doing that. And finally, I mean, the ultimate goal is, as much as we love Andrew and Nerman and their book, we truly want there to be fewer puzzlers. Unfortunately, reality or history shows us that it will just be different puzzlers and they can just publish a new edition, but our goal is to reduce them. So for the meat of the talk, I want to talk a little bit about why we're so excited about Java 8 and what we're doing with this new support. So probably the biggest feature in terms of, let me just check how we're doing on time. Okay, I think I have time to take a sip of water. Any questions so far? Okay, so yeah, this is the trait encoding. So as you may have seen, if you ever unleashed a Java decompiler on your Scala bytecode, traits compile to a lot of compiler magic, and you get an interface and a class with a lot of static methods and fields and so on that are a result of the mismatch between what we think of as traits and what is available on the platform. And so that gap has gotten a lot smaller with Java 8. There's still a fair amount of compiler magic that we need to do, and I'll talk a little bit about that later. But now at least a trait compiles one-on-one with an interface. And so I could stop the presentation right there and consider the release done. I'm very excited about that. It also allowed us to cut a lot of internal complication in the Scala compiler because you have one entity that needs to be compiled in two, and then methods or symbols are entered in one of them. You need to keep them up in sync and so on. There's a highly over-constrained system of transformations and keeping stuff in sync and needing to duplicate them early enough and so on. Erasure bugs and you name it. It was very complicated to keep everything in sync. So now that's gone. A lot of code removed from the compiler, a lot of maintenance burden gone. So Jason and I, Jason led the effort, and we both spent a lot of time working on that. That was a huge effort, but it was just merged, and basically has been on Maven for a week now, and we'll announce today probably if I get the pull request merged after the talk. So yeah, we're basically going to take the next month or so to refine this in M5, but the work is essentially done. I'll talk a little bit later about the kind of glue code that you get in subclasses of traits. But this ties into the other feature that is big into 12, which is that our function representation, our canonical classes that ship with the standard library that represent function types, now compile to Java's notion of a functional interface. And so it fits really well with what Java did. And I mean, that's always been our goal, by the way. Like whenever something on the Java platform is available, of course we will use it, and of course we'll align with it, because we can never do a better job with the GC and the JIT than the JVM does, and that's obviously been huge for Scala. So as I said, traits are still pretty magical. You can define fields in traits, which is not available as such in Java, so that compiles into getters and setters, and an obligation of mixing in a field into any class that extends that trait. So you can see the binary compatibility ramifications of that. When you add a field to a trait, you'll have to retroactively add a field to all the subclasses of that trait. And that's not something that falls out from the fact that a trait compiles to an interface. So that's still something that you need to be aware of when you evolve your traits. Same thing for having statements in the bodies of your traits. So if you have like a print line in there, and by the way, a field is basically an initialization effect, that's not something that we can represent easily. So that also requires changes to the subclasses that implement those traits. Same thing, a trait can declare that it extends a class, but obviously it can't do that at the interface level. It needs to do that later when the interface is implemented in the subclass. We actually, when you write super in Scala, that becomes a method call, an abstract method call that needs to be implemented once we know what the linearization is. And in Scala, you only know the order of all the superclasses or the linearization once you make a class. The class doesn't have to be concrete, but as long as you're just composing traits, you don't know from if you're in a certain class what super means, and when you're in a certain trait, you don't know what super means until you mix all those traits together into a class. And so we need to abstract over that and implement that when you finally get to the level that you're actually talking about a real class. Yeah, the reason I tripped up is that usually we think of traits as classes, but they have restrictions or different semantics. And for the same reason, we need to implement forwarders when you have two concrete methods implemented by different traits in the hierarchy. You need to tell the JVM which one to call when you're looking at the runtime type. And of course, these are all things that are brittle. When you're evolving your traits, your existing code will need to be recompiled. So a kind of a neat side note here on this is that now that we don't have any implementation classes, it also means that we didn't have a good host for a lot of the caching that we do behind the scenes. Like, it's a little obscure, but Scala has this notation for symbols, which are interned, and you can just write, apostrophe blah, and you'll be sure there's only one instance, but how do you do that? Well, invokedynamic now provides a great way of doing that. And so when the bootstrap method is run for the invokedynamic instruction, the call site is essentially replaced by the value that has been computed at that time. And so internally, that's available to you, for example, if you're a macro author, which you're not, because I just told you shouldn't write any. But if you were to do that, then you could use that to emit invoke dynamics from your macros, for example, and do some pretty cool stuff. The pull request has a test case with an example. So, I mean, this is one of the examples of, honestly, stuff that we hadn't thought of that was going to matter once we get rid of implementation classes, but in hindsight is actually pretty exciting. We have more plans to leverage invoke dynamic, for example, for our structural types, but we haven't had time to do that yet. So for a while now, yes, Ryan?
Good. I just want to amplify that. Everyone thought invoke dynamic when we added it was all about dynamic languages, but the static languages are really the ones we want to count on.
Yes, thank you. Yeah, we're very excited about it, and yeah, we definitely have. We've only started scratching what we could do with it. Invoke dynamic based lambdas have been supported since 2.11. Under a flag there, because obviously we don't by default require Java 8. We can't do that to you on 2.11, so late in the cycle. But our usual guiding principle is just emit the same bytecode as Java does when possible. And so that's what we do for functional literals now. And we get all these things for free. Single abstract methods are I was going to call it a very elegant retrofit of functions in Java, even if I hadn't known you were here. But yes, seriously, I really like it, and so we've been working on support for that in the type checker in 2.11, and added backend support for that in 2.12, so that no matter whether you target a built-in Scala function n type or any other type that is a single abstract method, in Java speak, you get the same instructions to spin up that class. We actually go a little bit further, and for backwards compatibility, we actually there are more classes that you can spin up, but then the compiler has to do that statically at compile time. For example, when you target a class or something like that has one abstract method. And we have a couple other corner cases where it's nicer in the language to not show you the difference. But in general, you will get the same bytecode as Java. And so that makes it a lot nicer to call Java 8 APIs from Scala, and I'll give you an example of that. And the main thing here, I won't go in detail, but it's been really hard to really make that as, like, Java 8 type inference is really hard to integrate into the Scala style of type inference, mostly because of variance and wildcards. And so we've had to kind of give up there, and certain times you have to supply type arguments to methods where the Java compiler knows what it is, and we simply can't. Not ever could, but not can't within the time that's available to us. I'm not gonna do a REPL session for you, but I'm happy to do some live coding during the questions time. But here's a random snippet that I found on the internet that I translated to Scala for you. And I mean, really, the main thing is to show a couple of examples and see that it's essentially the same stuff. So, I mean, instead of having method handles, we use our magic underscore, but otherwise, it's basically the same thing. I mean, stop me if there is a question or if I scroll too quickly, but I think really the lesson here is basically you use the APIs from Scala as you would in Java, with here and there a little syntactic nicety with the underscore, but not a huge deal. Here is an example of when you kind of change types intermediate in a longer pipeline, you sometimes have to tell the Scala compiler, even though the Java compiler knows, and that's because internally we just give up when we see too many wildcards. And yeah, sorry guys. I see some ways out of this, but it'll be tricky. Yeah, so the rest of this scrolling is basically to just show you, it all works. And I'm sure you would trust me even if I just told you that. So let's single out one of those examples. And if you write this, what actually happens during compilation? So, well, the type checker says, while filter takes a predicate, and here you're supplying what I think of as a function 1, those are compatible because I know that later I can do SAM conversion. And so the type checker says, yeah, that's all good. And then uncurry, which is kind of our phase that turns all the functional stuff into more method-based stuff, we'll say, oh, okay, well, let me pull out the method, the body to a method, which is actually pretty important to keep, originally even, to keep your class files small, because now all the constants that result from compiling the body there stay in the original site, and the class that was originally derived from this little bit here had the very minimum of information. Now none of that matters anymore because we use Lambda Meta Factory to spin up those classes at linkage time. But a little bit more concretely, internally what the compiler is really doing is just simplifying function nodes until they all look like a list of arguments with types that I know, and then a call of a method with those arguments. Yes, question?
Will this conflict, so in at least in Scala 2.10, for the collections, closures are generic, right? Like even if you specify a specific type of thing, they get turned to the end. Will this conflict with that?
And what exactly is the problem there? That you, like, because you're saying in terms of specialization and boxing and unboxing and so on, or? Yeah. So the question was, will this give me more precise types for my closure so I can avoid boxing and unboxing more? Yeah, to a certain extent, yes, because Lambda Meta Factory, I don't know the exact implementation details there, but they do provide, I'm sure Brian can correct me, they do provide some automatic bridging between, you can specify the instantiated generic type for the SAM and then the one that's actually there, and there were some adaptations like widening and so on are done behind the scenes for you, and I imagine that the JIT can optimize those away. But ultimately, for Scala code, the way that we've been doing specialization doesn't really fit well with the way that SAM types work. I can talk about that a little bit later. But mostly here, to avoid boxing and unboxing, you really need the optimizer that will inline closures, and eventually you get to a point that's simple enough that the JITs, escape analysis, and so on, will work, and then we can just pass it on to those guys. Yeah, so the key message here is that what I wanted you to take away with here is that before, this resulted in lots of classes that were emitted and that you shipped in your jar files. Now this little closure here, which used to be an anonymous subclass of function 1, is just an invoke dynamic with a little bit of information saying like, hey, spin up a subclass of predicate. Well, it's not really a class, I guess, technically, but and the method that you need to implement in that class is the single abstract method that you need to implement is test. And that saves a lot in bytecode and in load time and so on, and gives more opportunities for optimization at runtime later too. So, and you can see that in the REPL, you can just define your own SAM type and tell the compiler by giving it this target type, the compiler will see this function literal, which is really x2 x of dot two string, and it'll say, hey, this is a function literal, but I'm supposed to give you an instance of my SAM, and it knows that it can do that by emitting an invoke dynamic that ultimately will create the class the first time and then create instances of that class, conceptually. And so you will get the same representation as you would get for function literals in Java 8. So there are a couple of changes at the source level. Previously, you could do this manually by writing implicit conversions from Scala's native function types to your custom domain-specific function types. They wouldn't let you do like argument type inference for your closures if you didn't specify the type of your arguments there. But people use them. So those implicits are no longer applied because we can go more directly to the representation and also give you better type inference in return for that. And sadly, overloading, again, we prove that you should just don't do it. Just don't overload anything, please. The compiler thanks you. So to explain why, we have a lot of. I mean, I can only really call them hacks in the type checker that try to eliminate as many possible candidates from an overloaded invocation so that we can solve this conundrum of having to infer argument types for function literals supplied to higher order methods, and at the same time infer the actual argument types that we need to instantiate in the type parameters of those generic methods. So it's really a chicken and the egg problem, and so we need to somehow first narrow down the candidates that are overloaded to one, and we normally do that by looking at the arity of the function that's applied. That's like a really easy thing that you can do without fully type checking your argument. You can just say, hey, this looks like a function of arity 1. None of the others could possibly apply. Now you have 2 because the comparator and the function 2 that we support in the overload are basically, you can't tell the difference when you're first doing your pruning and saying, well, I'm supplying this function, I don't know how to proceed. So on the first line here, the compiler just says, sorry, I don't know what to do here. I can't infer argument types for this. And by the way, this is just beautiful, beautiful syntax that is short for this, okay? Except that the ints are missing, of course, up there. And that's the key difference. So in our second try, and I swear I got this right on the second try, you could tell the compiler, hey, there is no overloading going on here, just pick the first one. Okay, and then it knows and it can propagate that information back down to your function literal and infer that in fact its 2 arguments have type int. Now you could also just tell it that you're supplying a function literal that takes 2 ints, and then I'll say, fine, I know that it's going to be this one because actually that's the more general one because you can convert a function literal to either comparator or function 2, but you can't do the converse. So if you were given a comparator, you couldn't convert it to a function 2. So that's why we picked the last overload. So that's a really unfortunate breakage of existing programs. This is not a random thing I came up with. This broke an ACA, and we have about 1.5 million lines of code in our community build that we make sure passes before we do a release. And I want to say I had to fix about 4 lines of code or something like that. So it's not super common, but common enough that we're concerned. Because, I mean, we really would like 0 lines out of 1 million to break on an upgrade like this. So yeah, we'll hear what you guys think after trying M4. And there are a couple of things that we could do to make this even more ugly but work, but I'd rather not. So I hope that we can we can adapt to this change. I'm doing on time. Okay, so I should, yeah, okay. So I mentioned earlier that specialization doesn't really work very well with SAMs. Given the time, I'm going to leave that to the Q&A. I just wanted to give some personal opinions, call it a rant about functional programming, and when I talk about functional programming, what the images that kind of is projected in my head. I'm not saying this is functional programming or something like that, but to me, it's the natural complement to object-oriented programming. You're dealing with smaller units of functionality, and you're assuming that the set of types are known, whereas OO is kind of the opposite. You're dealing with this huge problem domain, and it evolves over time, and that's kind of how OO was invented to simulate these things or to model these things. FP kind of takes the opposite or dual approach, I would say. I mean, and maybe that's just the way that I was taught in school, I don't know. And so in general, my idea of programming is that you want to express yourself concisely, you want to be able to understand other people's code, and you need to maintain that code. So these are three things that need to be, they go together, and you can't just like say, I want a very expressive language, I don't care about anybody reading my code or ever maintaining this. You need all of them, okay? And I'm not saying this is exhaustive, but this is how I judge a new feature or design. And to me, programming is a pragmatic thing. It's engineering. It's not really science. I mean, there's science behind it, but the act of isn't one-on-one with maths or something like that. So you want to divide your problem, and you need the right size of abstraction for that. Sometimes that's a function, sometimes that's an object, sometimes it's a class, whatever, or a module, or a whole jar. And a lot of people get really hung up on purity as a defining characteristic for functional programming. You can do object-oriented programming without side effects. There's nothing key about objects that needs vars or that needs print line. That's not what it's about to me. And purity is great for understanding, great for scaling, great for maintenance. It's not necessarily great for expressivity. Sometimes it is nicer to write a var and be done with it. And so for maintenance, recomposing different abstractions safely, guided by types, is the other thing, right? I mean, a type system to me is you can't do without it when you're maintaining large code bases. And so the nice thing about what we have in Scala and Java 8 now is that you want the size of your abstractions to be just right. Sometimes you need something small, sometimes you need something big. There's no judgment here. Pick the one that's right for you. And you want to keep them together. So in Scala, you can nest methods into methods, because if that method is never going to get called from another method, why don't you just keep it with the other stuff that you're doing there? And that kind of uniformity that may seem gratuitous, I actually really like. I mean, you don't have to learn a rule of when it's good to nest something in something else and when it isn't. And you get this kind of regularity, which to me, as programmers who tend to be more OCD, I guess, or at least I'm speaking for myself here, it's nice to not have exceptions to those rules. It makes our lives a lot harder. Doing incremental compilation and stuff like that is actually, it suffers for that kind of generality. But at the same time, don't overdo abstractions. Okay, abstractions are great when they help you maintain and express yourself and understand code, but sometimes they can just do exactly the opposite. And start out with a val. If it actually is nicer with a var, why not? Just don't write global ones, okay? Everything is an expression. That's another uniform rule that actually simplifies things. We don't need a special function type because unit is just another type. And that falls out from the idea that statements aren't that special. They're just expressions that evaluate to the single uninteresting value of unit. And pattern matching is another thing that, I'm particularly fond of because I re-implemented the pattern matcher in 2.10, so I'm a little biased, but I love it. And when you believe that the set of types is fixed or changes very little, then it's great to have the compiler check that you're covering all the known types right now in your universe, covering all the cases that you're destructing from a given original type. And I think very often that's the way that we program. We don't constantly add new subclasses to existing things. We know that it's going to be one of three. Why wouldn't you want the compiler to make sure that that you're covering all of those? And another somehow controversial thing is type description comes after because they're optional. And that goes with maintenance. Type inference avoids boilerplate code that needs to be maintained. But don't go overboard with that either. Types are documentation. You don't want to leave off the result types of public methods. Just write the thing because it tells your future you if this thing doesn't compile anymore, it's probably because you messed up a type somewhere. If you don't write a type there, and you can get a really long chain of changes propagating. So that's bad for binary compatibility. It's bad for understanding. It's just bad. Okay, it's just bad. And we apply that idea of the best types are unseen. For example, with definition side variance. And I may have said that. I may not have said that. I mean, you can quote me on it now. But it's actually a feature. You can trust the type checker that it'll tell you, like, ascribing variance to a type parameter is a promise, just like a bound. You're promising you will only use it in a covariant or a contravariant position. And you're saying something about that type parameter. You're saying it's input, it's output. And then the compiler says, let's see if that's true, what you're claiming here. And that's what it's doing for so many other things that you're saying about your types. And that way, we don't get into situations like this. Yeah, I'm just not going to say anything about that. I know this is the only way that you can do it, given where you started, but I'm just glad that we started with definition side variance. And that leaves me to thank you for sticking out this whole session with me, and I'll be happy to take questions. Thank you.
So with the change in the SAM and the function end, like compiling down to more native Java code, can we expect like any kind of like performance increase from that?
Definitely.
And do you have any insight about what that is?
Not yet. We just shipped M4, which was kind of the prerequisite to be able to do benchmarking.
And I guess, so do you have any idea what that means for like libraries that use a lot of that stuff, like Spark, for instance?
Mm-hmm. Well, so first of all, in terms of bytecode, it's easy to say, huge savings, huge savings. If you're very heavy on spinning on subclasses of anonymous classes of functions, anonymous subclasses of function types. Is this really water? Then yes, you're going to see a big savings. And that savings isn't just transmitting over the network. It's also parsing all the bytecode, loading it up. And the JVM has gotten really good. I mean, like, they've been hammered with people writing functions now that they finally can. Imagine all that pent up desire for functional programming in Java 8. And now everybody's doing it. And the JVM will better catch up and make that fast. And they are making it fast. So I kind of blindly trusted, but we will test it, and we have been, but I don't have any real results yet. But that's for sure something that we're doing in the next month.
Thank you.
Yeah, great question. I'll be around for happy hour if anyone has more questions. Thanks again.